Welcome you all to this webinar by Softcell Technologies, Enhanced Product Design with PTC Creo Simulation Solutions. For this session, we have Mr. Ratna Prasad, who will deliver the session. A brief introduction about Mr. Ratna Prasad. He's a seasoned professional with over 18 years of extensive experience in pre-sales, consulting, solution benchmarking, implementation, and corporate training in the CAD CAE domain, specializing in the PTC Creo and Ansys solutions. Mr. Ratna Prasad has conducted workshops and technical sessions at premier engineering institutions and IIT and delivered successful projects and engagements with leading organizations. Mr. Ratna holds master's degree from the in advanced manufacturing systems from JNT University, Hyderabad, and also has secured gold medal at university level at JNT University, Hyderabad. If you are a part of product design, R&D, simulation, or engineering innovation teams, this webinar is specially designed for you. Now, Mr. Ratna Prasad will take you through a quick overview of Softcell Technologies and then drive you to the PTC Creo solutions. Thank you.
Thank you, Tanvi. Is my voice audible? So good afternoon, everybody. Welcome you to this session on enhancing product design with PTC Creo Simulation Solutions. For the next 1 hour, I'll be taking you through the solutions that are there with PTC Creo in terms of simulation and all. Before I brief about the simulation solutions, I have a brief about our company, which is Softcell Technologies. So as Tanvi said, Softcell Technology Global Private Limited, we are a 35-year-old company, which is in engineering solutions and also in terms of system integration and mobility solutions as well. So these are some of the alliances which we have in terms of selling the solutions and also implementing them and helping customers adopt these solutions. Here in this engineering services dome business division is what we are representing here, where we are partnered with PTC and Ansys Segmetrics for their entire range of products and solutions. For example, if you look at PTC in terms of PTC Creo, which is 3D modeling and all CAD CAM CAE solutions, and also in terms of Ansys for their entire range of simulation solutions. Segmetrics for tolerance analysis solutions. So this is a brief about our company and what we do. And let us get into that topic today, which is enhancing product design with PTC Creo Simulation Solutions and all. So before that, I'll introduce this term, which is called a simulation-driven design. So basically, when we are looking at the traditional product development process, so every product development process, generally, it starts with a concept where that the concept will be realized as a detailed design, and then simulation comes into picture and then gets into manufacturing, and then the manufacturing is delivered in terms of drawings or whatever it may be. But if you look at these stages and all, simulation comes only when the product is completed, when the design is completed. When I say detailed design, it can be a 2D or it can be 3D and all. Once the 3D model is done, then we will be getting into validation phase, where we will be analyzing the model in terms of its strength or its operability or what is its life, etc. Different types of analysis that might be possible. So that way and all. So thing is that when we are doing this kind of a analysis and all, so what we are doing is we are actually, when there are some errors that are found in the terms of the when we are doing simulations, again we are going to go back to the either to the concept design phase or maybe to the detailed design phase, and then do it and all, rather than doing it and all. Then what will happen is, so what is happening is, So when we are looking at, suppose when you are finding some design flaws, when the simulation is happening, okay, again, we may be shifting to concept or we may be shifting to detailed design to try to find out where exactly the problem has come. Okay, so where a lot of time is getting wasted, okay, in terms of this one. So that is the reason actually when we are doing this, no, so when we are finding out, so if you look at this, so this process, whenever we are seeing, see here, when we are finding the problem here, when it is in simulation, no, we are going back and forth and going to the concept design or maybe the detailed design and trying to find out where exactly the problem has come. Okay, so where exactly the problem is identified and how does it is affecting the further processing of the model in terms of its manufacturing, all that and all. So rather than that, what is it that we wanted to do? So we will be doing back and forth and to and fro in terms of all this. Still, we find a proper solution where we can go ahead and do the manufacturing. So what is happening is because of these things, what will happen is because of this late stage analysis and all, no, it is actually time consuming, and again it may will be giving rise to a lot of costly design errors and a lot of analysis cycles or design cycles are getting elongated and all. So what will, so that is where actually the concept is coming is like, why don't we get into the analysis early at the design? Why don't we do it in concept design phase, or why don't we do it detailed design phase? All that. So that is where we are have this concept which is called as simulation driven design. Simulation, when you're talking about simulation driven design, so this is what we will be talking about. Simulation driven design, like when right at the concept level. So when we are designing a concept, are we optimizing it, or are we designing the right concept? Are we designing the best concept, or do we have time to explore different alternatives so that we will finalize a best concept to proceed with the analysis, so that we will not be cutting back into the different phases like how we saw it in the previous slide, no, where traditional process of design, where concept design you are going it, design detailed design you are going it, and also when we are doing the analysis, how much time it is getting actually. Are we going to the traditional way of process where you do the you get the model and then do the meshing and apply the constraints, apply the loads, apply, then go to the design phase, validate it, all that and all. So that process is also there, but what we are trying to do it here is, when you are talking about simulation driven design, employing simulation right at the concept level only. Okay, so when you are doing at the concept level, basically when you have suppose for example, if I'm having 10 concepts that is created and there is only one analysis engineer is there, so these 10 concepts, what happens is these 10 concepts that analysis engineer has to evaluate it, so that he will be telling to the design engineers which is the best concept, so that they can go ahead with the detailed design, maybe in 2D 3D, and then proceed with the further product in the product analysis cycle and all. So rather than that, if we the design engineer or can be given a tools where he can himself check the concept design validation right at this tool, no? So there actually it should not be like, again he should not take time in terms of creating the mesh and doing spending a lot of time in terms of pre-processing all that. Rather than that, he can quickly wanted to understand the concept validation, so that you can, that is where real-time simulation comes into picture, and we'll see what are the different solutions that are available with PTC Creo in that phase. And also when you wanted to do more in-depth analysis, something like drop test, impact test, or maybe the vibration. So where a lot of high fidelity simulations that are required. And when you wanted to get in depth in terms of multi-physics, coupled analysis, all those where basically the analysis which should be performed by analysts or experts. No? So what are the different solutions that are available? Okay, so all this, what the crux of this thing is that when we are doing this late stage analysis, it doesn't meet the requirements of the design engineers or the analysts and all. So thing is that what we wanted to do is entirely transform this product development process by posting this use of simulation tools throughout the entire design life cycle, not only at the only at when the simulation phase, entire phases, be it concept design, be it design phase, be it validation phase, manufacturing, whatever it may be. Okay, so that's where we will learn the simulation driven design is what we are making the change, which is made possible through the CAD, advanced CAD and CAE tools. You're applying them at the different line stages. So unlike these traditional analysis tools, which basically what they target, no, they target the expertise of the analysts and experts, but this simulation driven design, no. So it is actually targeting the needs of the design engineers and using the early analysis to support and guide whenever there are a critical design decisions are there, which is respect to the simulation and analysis and all. So now when you look at this analysis and all, so if you hear generative design, real-time simulation, so traditional, so simulation driven design up to this and traditional simulation, you can continue with that. Now let us see what are the different solutions that are there in this one. So when you're looking at simulation driven design, so we are having early analysis data to guide and design development decisions during the early stages of design. And also when you're looking traditional analysis, you need high fidelity analysis data, okay, and also to evaluate and optimize the design performance and quality. So when you look at PTC, it provides you a complete suite of these simulation and analysis solutions, supporting simulation driven design, and also at the same time also to support traditional analysis also. So when we are introducing the simulation driven design, we are positioning the need for early analysis data to guide the design and development, and also in terms of traditional analysis, no, if we wanted to target the needs of customers that are reliant on analysts and experts performing late stage analysis and all. So it depends on what is the requirement, what is the need, and what is the stage that we are in, so that depending on that, what are the different solutions that we can use it here. So here, when you look at simulation and analysis solutions with respect to PTC Creo, so you have simulation live, generative design, kinematic analysis, behavior modeling, mold analysis, clearance and creepage, tolerance analysis, human factors. And when it comes to high fidelity analysis, you have mechanism dynamics, simulation, advanced simulation, and fatigue analysis and flow analysis as well. And PTC also has partnered with ANSYS also to bring in the capabilities of ANSYS in terms of its pre-processing capabilities, be it the solver, what ANSYS is about, and also what the kind of elements or the mesh or the processing which is there in the pre-processing, right? The types of element flexibility and the meshing flexibility, and how good you will do the meshing, and what are the results accuracy. So there are solutions which are tied up ANSYS and developed, which are called as ANSYS simulation, which we will be discussing it further actually. Okay, so now when you look at this simulation live, so I was telling about an example where you have 10 concepts are created, and in that, how do we take it to the next phase to decide which are the concepts that quickly has to be validated, all this. So this simulation live, what it does is, it capitalizes on the capability of graphic processing in it rather than CPU capability, CPU capacity. And generally, when we are doing the analysis, people will say, right, CPU capacity where 8 core, 12 core, like that and all. Rather than that, this simulation live is actually developed in collaboration with ANSYS and also in terms of NVIDIA graphic cards, where it utilizes the capability of graphic processing in it, so that the simulation time is reduced drastically within minutes, or sometimes you can also expect the results coming in terms of seconds. Only thing is that the user, the engineer will only be concerned about what the constraints and loads that he has to apply along with the materials, and within no time he will be getting the results in terms of validating that concept, so that quickly decide if he has got 10 concepts, he can himself do that, rather than that particular concept getting into the analyst hands, and then he is taking his time going through a traditional process. No, he can quickly do that. So that's where this Creo simulation live, we can see here, we can make our design engine sensitive to the influence of the certain changes. Even when there is a change in the design, quickly you can incorporate that change in the design and quickly check it out whether this change is feasible or not to proceed further. Okay, so you can see here a simulation design point is down to an average of 15 minutes from a half day. That much drastic time reduction will be there with respect to simulation live when you are employing it for a analysis early in the design while you are at the concept design stage and all. So as it is, there are multiple capabilities that are there with respect to simulation live. You have simulation live and simulation advanced, where structural and thermal and fluid flow analysis supports are available here. Okay, and now this is actually, there is one more generative design. So we are not stressing much here, but generative design is one more analysis tool, which is basically helping you to create the best concept and optimize that concept with respect to the manufacturing processes that you are employing it, or maybe the materials, and what is the kind of a end product in terms of the concept design. So this generative design will help. And when it comes to kinematic analysis, okay, so generally when we are talking about this kinematics, generally people will say that when you have a moving components, okay, generally which is referred to something like geometry of motion. So whenever we are defining assemblies in Creo, users will apply real world constraints to define the assembly mechanisms and support kinematic motion analysis. So what happens is there's a mechanism design which is inbuilt in Creo. It supports this motion analysis, and also in terms of interference checking, and also whenever we are creating the motion parts and also motion envelopes and all. So this kinematic analysis is basically used to analyze this kinematic behavior in terms of measuring the position, velocity, and acceleration of objects. And mechanism design and kinematic analysis support the design and optimization of assembly mechanisms here. Okay, so if you look at this one, so when you look at this, the code that is given by Sandrock here, so they are using Creo mechanism design to provide the real-time motion analysis and also in terms of interference checking. So while doing so, they have reduced the design time by approximately 20 to 30%. This is also one of the analysis tool here. And another one is there is a mold analysis inside the Creo analysis solutions, which is powered by this Moldex 3D, which is a mold analysis software, which is the industry's leading injection molding software. So the capabilities which are integrated with Creo gives engineers and designers the ability to analyze design and molding parameters. At the same time, these results from mold analysis provide detailed information in terms of expert advice to help users identify and also to resolve design and moldability issues. Maybe that these issues which can spoil the quality of the injection molded parts, and also in terms of finding and resolving errors early in the design process, so that it will reduce the manufacturing cost, and also in terms of lengthy lead times associated with the late stage, and also this one. Okay, so if you look at the code given by one of the customer, whenever before they prior to using Creo mold analysis, they used to outsource the mold analysis at a cost of $5,000, and at the same time they purchased this, and they have reduced the cost as well as time in terms of for the communication between the user who is actually doing the outsourcing work and implementing it in-house. Now there is another analysis tool, which is Creo clearance and creepage analysis, which is basically used to identify and also resolve this electrical clearance and creepage design flaws. Basically, the designs, electrical designs, when you're doing it, they are validated and optimized for basically to what is the safety of the products, electrical product safety, what is the safety, and also at the same time improving the quality. And also because safety is of utmost importance, because the brand of the company is of utmost importance nowadays, right? When you are saying that this particular switch or this particular electrical appliances doesn't have any safety, that those kind of products will not find any market. And also where to reduce this product failures, and also sometimes you will be hearing these recalls of the products, and also warranty issues, at the same time repair costs also here. Okay, so this is also one of the customer, which is L&T Electrical and Automation, which is using this clearance and creepage analysis basically to validate and deliver quality switchgear products on time, and also at the same time under the budget actually. Okay, so this is another analysis solution, and another analysis solution is Creo tolerance analysis actually. Okay, so this is basically used to improve the quality and the manufacturability of products. Basically, whenever you're giving the analysis tolerance values of individual components in your assembly, and what will be the cumulative effect of all those tolerances onto the entire assembly operation and also manufacturability of that one. So this solution simplifies and also at the same time speeds up tolerance stack up and gap analysis, providing users with the information they need to identify, and also at the same time modify critical tolerances to achieve better quality and also better manufacturability goals. And what we will be doing here is standard analysis type statistical quality metrics that will be there, where this tolerance analysis supports this design for Six Sigma. If you wanted to go further, basically this is a 1D tool. When you wanted to explore in terms of 3D also, no, in terms of Six Sigma, all that. So CTOL option is also available where you wanted to explore it to 3D tool as well. Okay. So there is a quote here also. You can look at from electrical and automation, which is basically using this tolerance analysis. They are actually using for optimization and synthesis of tolerances using the worst case as well as statistical analysis methods. Okay, so basically what they achieved with this tolerance analysis is that reduce this part defects and also at the same time minimizing the warranty costs actually. So another one is human factors. Human factors is basically whenever we are in a machinery design or maybe in automotive segment, basically when I'm there in automotive segment, suppose I wanted to understand the ergonomics of the seating designs that we are actually manufacturing, or maybe we also wanted to understand what is the maneuverability of a person before whenever he is standing before a machine. Okay, what is his hand reach, what is his leg reach, and what is his eye purview, what are the different components that are visible with his eye purview. So those kind of analysis actually will be available in these human factors. Okay, so where basically this PTC, what it does provide is functionality in terms of supporting this human-centric design, and also we will be validating this health or safety and also workplace standards. Okay, so to enable this one, what we will do is we will call it as mannequin, the kind of a human that you are seeing before the machine. Those things we will be calling it as mannequin in PTC terminology. And also we will visualize and also assess what is the operation of the machine and what is reach and vision and all. Okay, so what we can also do is, apart from designing, so engineers also can define whether the when mannequin is standing before that, and what is the compliance with safety, and also what is the health and workplace standards, anything that is there with respect to analysis capabilities, no? So that we can analyze in terms of user comfort. For example, if you look at the seating systems in automotive, what is the user comfort, and also when you're carrying repetitive motions, something like lifting, lowering, or maybe the pushing and all, there are certain world standards that are there, something like RULA, SNOOC, and US standards will be there. So those kind of standards are followed by these things and all. So now if you look at this early analysis, when you look at this early analysis, which is simulation driven design, no? So these are the tools that are part of this simulation driven design. And now let us see what are the tools that are available in terms of high fidelity analysis. Okay, so when we are discussing the simulation driven design, there are many solutions that fall in the parameters of the discussion. So in addition to the structure, thermal, or modular mechanism, there are additional solutions. So basically to support in depth in terms of what are other requirements, something like so here if you look at our simulation driven design, we discussed it in terms of mold analysis, clearance and creepage, tolerance, human factors, all that. Now let us see what are the high fidelity analysis that are available in terms of other traditional types of analysis that we will be doing and all. So here this is Creo mechanism dynamics. So this is an extension to that Creo mechanism that we were discussing about kinematic analysis, where this particular Creo mechanism dynamics, it gives you a functionality wherein you wanted to analyze and also in terms of optimizing the dynamic performance of the mechanisms and all. So whenever there is a dynamic motion analysis is used, so it will be able to understand how these forces and torques acting on a system result in a motion of the system. Okay, so whenever we are performing this dynamic motion analysis, the solution computes the reactionary forces, whatever forces all that we are using, no? So what are the reaction forces that are generated, and also whenever that mechanism is placed in motion and all. So this reactionary forces when they are directly, so what happens is it will be calculating this reaction forces. Same forces we can take it to the Creo simulation and go ahead with conducting the structural analysis on the components. Same thing like that. So if you look at this example, customer companies like this College Park, no, which is using this simulation and as well as mechanism dynamics, basically to improve their design and performance of the products. So that food was designed to be 40% stronger and 10% lighter using the analysis solutions for refining and optimizing the design. This is the benefit they got it from employing the mechanism dynamics. Now, same way, so you have Creo simulation, which is basically when you wanted to do structural analysis and thermal analysis and model analysis. Okay, so these results, when you're talking about this in terms of traditional process only, wherein you have a model and then convert that into a FEM model and you apply the constraints and loads and materials, and then what is the type of analysis that you are actually requiring. If you are requiring something, some kind of structural results where stress, strain, deformation, etc., or thermal results, something like heat flow rate, or maybe depending on the conditions, whether it is as conduction, convection, radiation. And also when you wanted to do the vibration analysis, before you do vibration analysis, we need to do the model analysis to understand what are the critical nodes that are there, and also to proceed with the vibration analysis in terms of the time or frequency, or if it is any seismic effects are there, random vibration or shock, those kind of things. So this particular Creo simulation uses those example, and it follows this P element approach for creating the mesh. Okay, and also this fully integrated in terms with respect to the Creo model, the model which you are actually creating in Creo, directly taken into Creo simulate without any translation to any neutral format files. The analysis straight away happens on the model that you are designing in Creo with tight integration capabilities from Creo actually. So if you look at this example testimony from one of the customers, so where at Komatsu they are using Creo simulate during their design process, basically to analyze and validate the design of the 3D digital models, and the integral analysis capabilities with respect to Creo and Creo simulate has made them innovate more faster, and also in terms of reducing the reliance on physical prototyping, reducing the development cost, and at the same time improving their quality and all. Okay, so now in order to get into other advanced capabilities, Creo simulation, when you look at it, no, so static structural analysis and steady state heat transfer, and you have model analysis, and if you wanted to get into non-linear analysis, something like elastoplastic materials, and at the same time also I wanted to do transient heat transfer and vibration analysis. So all those things actually can do it in advanced simulation, where you can have more in-depth analysis conducted in terms of the capabilities. Solutions so include nonlinear materials in terms of nonlinear contact, and whenever there is a large deformation, and also in terms of pre-stress static, and also transient, both in terms of structural as well as thermal, and also in terms of results, in terms of also different convergence criteria that will be there, where you wanted to go with multi-pass adaptive methods, different methods that are available. So where you can go with advanced analysis in terms of structural, thermal, as well as model analysis, also in terms of nonlinear materials. And Creo Fatigue Advisor is another solution where we will be using it to predict the life of the metal structures whenever there is a repeated cyclic loads that are being applied. No? So then what we wanted to know how many number of cycles that we can use it, and also in terms of whenever we wanted to understand if at all any informed design decisions, we can also wanted to know any design flaws that are there early in the design, maybe 10,000 cycles if it is work, if it has to undergo. Is there any design flaws that may be coming under 9,000 cycles or maybe 8,000 cycles? So what this fatigue advisor will do is it will predict and validate the number of load cycles that designs can sustain before it gets into the failure and all. So the analysis which we'll be doing it on the digital models, which is basically visual analysis, it eliminates the high cost to create and test physical prototypes, rather than if we are not using it, maybe we need to do it physically, applying all the time. Suppose if we wanted to apply the same 10,000 cycles, it requires a lot of time, or maybe in terms of prototype also. Okay, so these things definitely it will be, what it will do is it will mitigate the risk of this product failure, or also in terms of warranty and liability. So here the example is given in terms of this is one of the Europe's largest independent supplier of lithium-ion battery systems. So this is actually using Creo fatigue advisor basically to analyze the long-term effects of this vibration, which are there in the internal components. There are internal components that are there. So what is the advantage that the customer has got is they have improved this quality and also reduced their design cycle time, depending on a lot of physical prototypes they used to use, and also consuming a lot of time in terms of cycles that they have to do it whenever there is a fatigue. And there is one more, which is Creo flow analysis. So whenever there is a medium, so suppose for example water, oil, or maybe some air also. For example, if I'm taking a CPU system, okay, suppose if I wanted to know what is the power, or what is the wattage of the fan that I need to install inside the CPU, so that I will have a cooling effect on my PCB components. So basically there comes in picture computation fluid dynamics. So here, when we are doing computational fluid dynamics, we need to understand what are the heat transfer effects of the medium, and how this fan gives that ambient air comes inside, and it gives it that cooling effect, so that components should not be spoiled, right? So this Creo flow analysis, which is actually powered by Cimerix, who are actually pioneers in this. So see this one, multipurpose computational fluid physics, and also in terms of slideshow is coming correctly. Okay, sorry. So when you are looking at this solution, no, we will provide this. What we can is we can analyze and understand internal and external flows, allowing engineers to gain that early insight into that one. Is it coming? It is one slide. Okay, so the solution, what we are, sorry, this Creo flow analysis, no, what it does is the CFD analysis capabilities when you wanted to identify and also resolve design flaws early in the process. Okay, so these designs and are validated and optimized to improve the quality, performance, and mitigate risk. Different options that are available in terms of the things that you want is whether you have a only one medium, air as a medium, or is there any air and is there any other gas, or maybe liquids if you are using it, no? So is there any different types of liquids, or the mixed medium is there, or is there any something like whenever we are actually working with centrifugal pumps, this cavitation effects will be there, which will be damaging the centrifugal fans, centrifugal pumps and all, no? So how do we understand these cavitation effects? Also in terms of understanding in terms of any mixed particles motion, streamlines, straight lines and all. So all this analysis options are carried out in Creo flow analysis, which is powered by Cimerix here. Okay, for example, if you look at this, the example which you're seeing it here. So this clear motion, no, they actually developed this first proactive ride system that transforms that way cars ride and handle. So this company is the flow analysis for designing and developing the GenShock. This is the product name actually. So this analysis which they conducted, they almost got somewhere around 2% of uncalibrated predictions when they are doing the Creo flow analysis. No? So it resulted in a 3x improvement in terms of system efficiency compared to the previous version of the product which they developed. And so if you look at this Creo Ansys simulation, so I was telling about Creo Ansys simulation, right? So Creo Ansys, this product is actually developed in collaboration with Ansys. Okay, so which is basically I was telling about the strategic partnership between Ansys and PTC. Okay, so this helps you deliver that, what are the speed and accuracy of Ansys Workbench, which is actually running inside Creo, and the solver and meshing technology which Ansys simulation is using, the same technology is powered and uses this Ansys Workbench, which is there in this one. And so whenever you're having this Ansys and all, no, so because when you look at this, as of now, Creo Ansys simulation, structural and thermal solutions has been embedded, and there's a roadmap to develop it into other solutions as well. One is in terms of this one. Now, when you look at these solutions and all, so when we are looking at also why anyone has looking at simulation solution is in terms of its so when first we talked about, so we spoke about simulation driven design. So which is basically whenever we are having this product development efficiency, and also it's not that we will be developing the products which are good products taking longer design cycles or longer cycles to market. We should also have what is the shorter time to market, because if our product is not coming to the market at the same time, even though you're designing and all, by the time if any of our competitor comes to the market and they will be releasing, they will occupy that market. By the time we will get into the market, we will not have any scope in terms of that one. So that's where these things are gaining importance, where the innovation, the kind of a concept design that is coming up, and also at the same time we should not be compromising on the quality. It should not be that we have a less time and we should have some substandard products that are delivered, where we will also be compromising on the quality, and at the same time we will also not demand the premium for our products and all, where our profitability will get affected and all. And at the same time competitive products, and also a dependency on the prototypes. Dependency on the prototype will be reduced a lot in terms of quality, and also reducing the warranty liability and revenue exposure, because when you look at the components, some of the OEMs, for example, if you look at automotive and all, mostly they will be getting their revenue in terms of spare parts and all. So when you have a product which is designed wrong, for example, we have been seeing, right, many times we have been hearing they're recalling some of the parts and all that and all. So if, for example, if the part that is being recalled, for example, it is some 1,000 rupees or maybe 10,000 rupees, maybe if the vehicle is sold somewhere around 10,000 vehicles have been sold, it becomes a burden on the company, because while they are designing, while they are doing the analysis, if they have not done properly using all these tools, no, that becomes a liability where warranty costs will increase. Okay, and so that is where, if you're looking at this one, no, so here, so what engineers need to do is, we'll have this is where people will be looking at analysis tools, where we'll have a better understanding of the product performance, validate design and developmentations as they work, and also we can identify and resolve, not only identifying it, resolving it right at the starting stage itself. At the same time, optimize the designs and reduce lengthy design and analysis cycles and all. Okay, so if you look at this example, no, so this is one customer survey. So there's by Tech Clarity. So this is some of the study, if you are looking at, no, what is the competitive differentiation. For example, what we already know, customers need simulation. Okay, when customers were asked what will make products more competitive over the next 5 years, customers identified quality, reliability, cost, and brand reputation and innovation, all of which can be achieved or improved whenever we are actually employing the right simulation tools for guiding the engineers, and also guiding the analysts, and also validate the designs, and also take the developmentations quickly and all. For example, if you look at this one, 80% is quality, 67% is reliability, and 58% cost, 42% brand reputation, 42% is in terms of innovation and all. Okay, so increase this one. So here 95% responded agree when design is used, and also there is a wrong notion or something like analysis is something which should be done by the analysts only. And sometimes I keep hearing, whenever we are giving a demonstration of our simulation products also to the design engineers, is like no, this is this finite element analysis, FEA concepts. No, finite element concept is something which some people like MTech holders, MTech degree holders, or people who are well versed with the analysis process, those things. So it's not like that. Actually, companies are developing. Even if you look at PTC, also the simulation-driven design products which we are discussing. No, it's all aimed at increasing the capability of design engineers so that they can straight away use it. It doesn't require a great learning curve, or it doesn't require a lengthy learning curve and all. Okay, so here if you look at this one, no, so this is what the concern whenever we are asking. No, 60% of them says that simulation catches problems sooner. Simulation reduces rework, increases design assurance. That is, they are agreeing, but at the same time hesitant to employ tools, hesitant to give the tools to the design engineers, because all the things, when if we are depending on design engineers doing the analysis, all are worried whether to give the tools to them or they are will be done. So if we are giving something, for example, like Creo Simulation Live, if we are giving to the design engineer, they quickly, rather than depending on the analyst, no, they quickly analyze and tell which is the best concept, so that they can go ahead, rather than waiting at the queue with the analyst to complete the traditional analysis process and get into the analysis, which is lengthy and all. Okay, so this is one thing. And so this is where you can see here, ease of is based on 30-year-old perception and also believe about analysis. And there actually you can see that Creo, and so Creo simulation, quickly it gives the results and all. Okay, so not only that one, and also the results that we are getting it now, it is fast, results are fast, and at the same time accurate also in terms of this one. Okay, so these are the simulation driven design solutions which we discussed. One is a generative topology and a generative design extension, which is a cloud based, and you have a Creo Simulation Live and Creo Simulation Live Advanced, and Creo Simulation Ansys Simulation. You have a basic as well as advanced also, depending on which is the phase that we wanted to use, whether it is concept design or design phase or validation phase and manufacturing phase, in terms of speed, simulation, and also the fidelity, where exactly this one. Okay, so if you look at this, the PTC and Ansys partnership, no, if you look at this one, this gives you a best-in-class design and also simulation capabilities for the design engineer as well as the engineers and all. So if you look at Creo Simulation Live, it is integration of this Ansys Discovery Simulation Engine running in Creo for providing real-time analysis for all this analysis, whether it is structural, thermal, model, maybe in terms of vibration, and at the same time fluid flow also. And Ansys simulation, you will have high fidelity in terms of thermal, structural, and model simulation, basically aimed at used by the design engineers whenever you wanted to have this design refinement or also validation, which is powered by Ansys and all. Okay, and at the same time, if you look at Ansys Simulation Advanced, you have nonlinear capabilities in terms of contact and also in terms of material, and also in terms of coupled analysis. So because whenever we are talking about multi-physics, we may expect multiple physics at the same time, right? Maybe there can be deformation, or there can be temperature, there can be heat flow, all that. So how do we do that? Those kind of things, when we need to combine structural as well as thermal simulations also, we can do that as well here. Okay, and so these are the things here. So Creo Simulation Live and behavior modeling extension is basically to optimize your designs and all. So what are the designs? You have a goal. So for example, if I have a goal of stress or maybe the deformation, in order to achieve that goal, what would be the design that I need to alternate? So those things actually here. Okay, so in a nutshell, so these are the advantages when you look at simulation driven design. So one is lower life cycle cost and reduce the time to market, and at the same time is designed to realize price premium. So we are actually producing quality products so that we will not be compromising in the price for our products, and quality and performance, and at the same time reduce the product development cost. Okay, so this is it from my side. So here we just briefly discuss, since the solutions are many, so we briefly discussed about what exactly these solutions will do. And so if you any of the solutions are matching to requirements, or if you wanted to know more details about any of the solutions that we discussed today, so we are happy to engage with you and discuss in detail, so that we will demonstrate with live examples in terms of benefiting your processes for these analysis solutions, which are right away there with PTC Creo. Okay, which are all integrated solutions with PTC Creo. Yeah, thank you. So if you have any queries and all, please type the queries so that I'll take up that queries and all. Yeah, along with me, my colleague Anup also is there, so he will also be taking up the queries and all. Yeah. Regarding the Creo Ansys simulation, does it use the same Ansys solver, and does it have access to nonlinear contacts? See, as I said, it uses the same Ansys solver only. And as of now, the Ansys capability and Ansys analysis capabilities that are there in Creo Ansys simulation are a subset of whatever these there in Ansys workbench. And yes, when you have Ansys Simulation Advanced, no Creo Ansys Simulation Advanced, there you will have this nonlinear contact option also.
Hi, this is Rishal here. As you guys saw the complete overview of PTC's simulation solutions, what are available, which are embedded in Creo. One thing we'd like to highlight, right, the PTC simulation add-ons are designed in such a way that the design engineers are able to do simulation activity. As you all are aware, design and simulation are typically run as two separate teams, and simulation teams require very high-end simulation systems, hardware, and a lot of capabilities, and a lot of understanding on the simulation subject and all. But the PTC's simulation solutions are designed in such a way that a design engineer is able to do the simulation activities, because it uses the pre-processing, which is very simple and automated process, and the engine backside is the Ansys engine. So that will give you a direction. Are you guys going in the right direction or not? So number of iteration required to do full-fledged simulation would get drastically reduced, because your each product completes design is simulation driven. So number of simulation iterations also will get reduced. And design engineers only can do simulation at their level and get a direction whether they are going the right direction or not, and then you can go for a final iteration with the simulation team. So in that way, the simulation team also can do number of more simulations, and if the simulation team is overloaded, the design team can also contribute the simulation activity, and they will be able to do simulations quickly and faster. Yeah, this is something I wanted to add. Yeah.
See, actually, there is one more query. We can control meshing using tools like splicing and body splitting, and also how to closely do the simulation results use in Creo compared with those from Ansys. See, when you're looking at splitting or when you are saying also in terms of body splitting and slicing, no, these are mostly related with the body controls and all when we are doing the meshing and all. So those tools are very much available. And also in terms of this results comparison with respect to Creo, Ansys simulation and Ansys, no, both will be similar only because the solver is being used either both in Ansys as well as Creo Ansys simulation or same solvers, which are like Shishal told, same solver is being used here.
But we are not saying that we will replace Ansys or any other simulation software. We are trying to tell you guys that we will help you with simulation results. The accuracy might not be 100% same as Ansys or any other simulation software, but it will give you a direction whether you are going in the right direction or what. So we are not trying to replace simulation products, but we are trying to reduce the number of iteration in simulations. Is what we would like to highlight.
So adding to Shishal only, so that's what I was telling, right? This so the capabilities as of now it is there as it's a subset of the full-fledged Ansys workbench solutions that we have now. Yeah.
Yeah.
It's basically like PTCS Ansys with that strategic partnership between PTC and Ansys. No? So the CAD. So if you look at the Creo Ansys simulation, that interface will be Creo interface, and the Ansys capabilities will be working when you are getting into Creo Ansys simulation here. It's a different from the Ansys workbench type of a process where you will create multiple projects and then do it. No, it's not that way. So the front end CAD will be PTC Creo and with added capabilities from Creo Ansys simulation.
So companies who don't do simulation and want to get into simulation, maybe Creo and Ansys simulation solutions could be an entry point for you to do in-house simulation activity and slowly increase your simulation capabilities. Have any other doubts, queries, feel free to reach us. If you want a detailed session on different add-ons of simulation, we can have a dedicated session for you people. Please feel free to reach us for that. Yeah, Ratna, I think should be fine. Anup, Tanvi, anything you want to say or?
Yeah, Anup. Okay.
Okay, then.
Is that
Thank you,
features complementary in the upcoming?
everybody.
So if you look at the one more query once again, is that features will be complementary in the upcoming? See, it's not Creo updates actually. As it is, the solutions which I showed, we discussed today, this comes as a add-on modules on top of your Creo. Okay, for example, if I'm saying Creo Simulate, it becomes as an add-on module. When you're using Creo, it comes as an add-on module as an application and works. And similarly, other things also, for example, mechanism dynamics and maybe the behavior modeling. So these things actually comes as an additional module which works on top of that one. It is not like you have Creo now and in that all this analysis will work. These are all add-on modules which are analysis related.
One thing we'd like to highlight that the Creo design essentials come with basic structural analysis capability without any limitations. So if you want to do structural analysis, you are happy to you can start using it from the design essential itself. Structural analysis capability will come, simulation elite will be there, part of your Creo design essential.
Okay, any other queries?
Yeah, it's restricted to plastic.
See, flow simulation, when you're talking about mold analysis, that's actually for plastics. Or Anup, you want to answer this? Mold analysis for plastics and castings.
Yeah, Ratna. So, the CFD analysis, flow analysis, which we have shown, it's basically related to the interaction of flow with your structure. Like say the oil flow on top of our mechanical equipments or airflow. So when we talk about the plastic flow, so it's basically the mold flow analysis, like how the material will be injected in the part. So that kind of simulation we don't cater in flow analysis. Same with the casting manufacturing flow analysis we don't cater. We cater the interaction of the flow with your component. It can be any medium, it can be oil, air, water. So that kind of CFD analysis we support in Creo. I hope I am clear.
Yeah. Okay. Yeah, basically that's what I was. That's what Anup, that's what she was asking. Asking Moldex add-on. That is mold analysis.
Okay.
So it supports only plastic injection molding, or it's also support castings also, metal injection.
Okay. No, it supports only plastic. That too at a component level. We cannot do a complete mold flow analysis here. Analysis like the gate location, the confidence of filling, if there are any sink marks. So that kind of at a part level we can do, but not for the complete mold. So that we can do using the CMA, that is Creo mold analysis tool.
Yeah, thanks, sir.
Any more queries?
So thanks everyone. Please, once the session is over, you'll be getting a link where you can give the feedback and all. And also please suggest us any of the other sessions that you want to be seen as webinars. Maybe it can be the add-on module, that other add-on modules available with the PTC Creo. Okay, or any other specific topics, all that. Thank you very much. Have a nice day. Thanks, Anup. Thanks, Shishir. Thanks, Tanvi.
Thank you all.
Thanks, everyone.
Thank you, Ratna. Thank you all.